So welcome to the 2022 graphics paper. This is question 5. So shown below is a hand sanitizer dispenser. So here we've got our hand sanitizer. In the space provided, draw a well-proportioned freehand sketch of the end view of the dispenser looking in the direction of the arrow A. So looking in here from A, we want a freehand sketch but well proportioned. Okay, so we need to look at lines in relation to each other. So I'm going to start off. I'm going to have my base, right? Let's do the overall shape first. So I'll run up that distance out there. It's going to be maybe twice that distance running up. So I'll draw a vertical line. That's approximately that's approximately twice that height there. Okay, and then other height running up. Okay, and we're adding on another little bit there. So this is approximately the outline of my shape. So what I want next is this black, or the black surface, which is outlined by an arc. Now at the end here I can see that that's going to be a straight line vertically. So, and that's approximately maybe about a third or a quarter of the way across. So 1, 2, 3. So about there, about a third. I'm going to draw a vertical line. They appear to be similar enough. And then that distance there, I'm going to step off vertically and about there, and I'll draw my arc, freehand arc. Okay, if I'm happy with that, then I am going to go over what I should have heavy. So vertical line, sloping surface there. That's a vertical line and my arc base. Okay, it doesn't say anything about adding shading or rendering, so we don't need to in this case. Okay, fairly happy with that. Part B. Shown below is the incomplete oblique drawing of the dispenser body without the logo. So we're forgetting about this logo. A 3D graphic is also shown. So here's our 3D graphic. Complete the oblique drawing of the dispenser. So oblique drawings is the front elevation, or the side elevation here, in this case, and then everything back at 45 degrees. So we've got a 45-degree line going there. So I'm going to project these elements back 45, also 45 here. Right, after that then, whatever this edge or angle this edge is at, I'm going to have a parallel line, and whatever angle this edge is at, I have a parallel line. Okay, that's one way of doing it. So I could just draw vertically here to find that point, and then slide in set squares to find that sloping surface. Or I can get this distance on my compass, so that distance there, swing an arc, and I can join those up. Right, so that's one way, and like I said, the other way, we can draw parallel to this edge, we're drawing vertical up, and parallel to this edge, we can draw across. And you see there I'm finding the same point. Okay, and I'll just draw in those edges heavier after. Okay, if I'm happy with that, then just double check I've got everything, all those edges back, Yeah, so that is my oblique drawing of that. Of the dispenser. So, part C, the logo for the hand sanitizer dispenser is shown across. So here's our logo that we can see. It is based on a parabola DOC. So DOC is our parabola with vertex O. So this is our vertex here at O. Redraw the parabola in the given rectangle ABCD. So ABCD, here's our ABCD, and we have D, O there, vertex and C. So we are going to divide up this line AO into equal parts. So a line at any angle and I'm going to step off a distance, divide it into 4 equal parts, 5 equal parts. 1, 2, 3, 4, 5. And number those 1, 2, 3, 4, 5. Slide and set squares then. So I'm going to join 5 back to A. Shall I do this in a colour just to make it pop off the sheet a little bit more? If you don't, I'm just doing it for your benefit. So these are all light lines. Right, just highlight those in yellow. Okay, and from the side containing the vertex, okay, and that's our axis running through the middle, I'm going to go parallel to my axis, so vertically down here. Okay, so that's the first bit. Next up now, I want to divide my AD into the same number of parts. So a line again at any angle. Step off 5 times again. 1, 2, 3, 4, and 5. Let's do this in another colour. Alright, and my slide and set squares. Okay. I should number these off. 1, 2, 3, 4, 5. And then these, the side, then they're going to join back up to my vertex. So from O, 1. Okay, so now where my line 1 meets 1, that'll be a point 2 and 2, 3 and 3, 4 and 4, and down to here. So this is my freehand curve. Looking to the point you're going to. And then I want to find the opposite side, so I could go through that whole construction again, but the quicker method is through axial symmetry, okay, because it's symmetrical. So I point 1, 2, 3 and 4. And I bring them across, and the distance from my axis of symmetry, that point, swing arc, finding the opposite side, same for point 3, 2, and 1. And now I can finish off my parabola. Okay, so that is the parabola drawn. Good. Complete the logo by constructing a tangent from point P to circle K. So we have point P and circle K. So here's my point P to circle K. So the construction for that is, if I have a point and a circle, I join the point to the center of the circle, I bisect that angle, or bisect that line, and then I should be able to draw a semicircle or a circle. I'll find my point of contact and my tangent. So here's point P, the line joining to K. I'll actually do this in colour just to make it pop off the page and make it clear for you. So P to K, technically it's already been done, already joined, but I'll join that there. Now I'm going to bisect that angle, or bisect that line, excuse me. Swing arc, to the other side, swing arc. Just highlight that for you. Join those 2 points. So now I have the center of that circle, or that line, so I can draw my semicircle, which would find it on one side. I'll draw a full circle here to find it on both sides. So here now will be a point of contact, and here will also be a point of contact. And I'll join from point P to that point of contact, and P on this side to that point of contact. Okay, complete the logo constructing the tangents. And just to finish it off, I will draw that little arc on the circle to finish that. Okay, and there's nothing then about adding colour or rendering or shading, so there we have question 5. Part C completed. Part D, the axonometric axis required for an isometric projection of the hand sanitizer dispenser are shown. So we've got our axonometric planes here, our axonometric setup here. The elevation and end view, so elevation and end view, and incomplete axonometric projection of the dispensers. So some of the projection here, the 3D projection, are given to us. A 3D graphic of the dispenser is also shown, so that's there just to help us to complete it. And they want us to complete the axonometric projection of the dispenser. So I'm going to start off by drawing this dispenser without the curve. Okay, the curve will come later. So my projections, because it's isometric, will be at 30 degrees and 30 degrees. So let's start off with this surface here. I have some of it, let's just finish it. So project back 30 degrees, okay, because this is the surface I'm looking for. It's been projected, so I just need to draw vertically up here to finish off the back surface, and 30 degrees. Okay, so that's my back surface. Let's go for this top element also. So here we have it projected, partially projected here, so we have one edge. So let's project back at 30 degrees here again, and 30 degrees. So where they meet up, I have my edge, I can join those up. That's the top surface. Okay, now let's find, we've got some of it, let's find that line. So that line projects down. We're back at 30 degrees. Okay, I know it's a vertical line and it's going to finish up. Just there with that. And also we could have projected it. That also finds position. So we have a lot of this done. Okay, we have that inside bit to do, but I'm just going to jump forward and do my section here. Okay, my curve. So I have an elevation and an end view, or an end elevation. Elevations have heights in common. Okay, so any height here, this is a corresponding height. So I'm going to find points on this edge, or on this curve. So any height there, and find a corresponding height along here. So if I wanted, I could go at 30 degrees, 60 degrees, but for the sake of this, I'm going to pick a point. Okay, I'll pick another point approximately here as well. Okay, if you wanted to pick maybe 5 points, you can, but I'm going with these particular ones. So the height then of these particular points, I'll step them off this way, just to show them as a height. So this is a height here. This is also a height. So I'll mark those just for your sake. Call that H1, plus H2. Okay, and they are points on it. Okay, so I'll call that point 1 and that point 2. I've already found this point projected down, and this one has been given to me over here. So I need to now find these points in this view. Okay, heights are common between views, so I'm going to get the height of point 1. And step it off there, and point 2. Step it off there. So I'll just use my color again just to indicate those heights. So that's at H1, H2, so point 2. And this here is point 1. Use my green. That's at the height of H1. Okay, just to make it clear for you. So I'm now going to project point 1 back to 30 degrees, point 2 back to 30 degrees, and then from my end view, point 1, matching up point 1, point 2, matching up with point 2. So that is my freehand curve. Down like so. Okay, and the last element then is we have this little section. So that's the elevation of it. So project it forward. It's going to be along that line, and it's in there in that distance. So project that up. That's fine. So just draw that in heavy, and it's going to be a vertical line from there. Vertical line, like so. So that's the axonometric view of that. No mention of shading or rendering, so that is completed. Always double check your 3D view just to ensure you have everything. We don't need to find the opposite side of it, the side we can't see. Okay, I'll show hidden detail because this is a 3D view. We only show hidden detail in orthographic views.